Okay, so this is the prompt 2 on the Wiggers diagram. So we'll go ahead and get started explaining that. So this is what your typical Wiggers diagram looks like. It's pretty confusing looking at all the lines, but we're going to correlate all of them together. So to start at the bottom, we're going to have a little beat up right here. So it's going to be areas of systole and diastole. So our area of systole is going to be during the contraction of the heart. So you're going to see a ventricular depolarization happening in this phase. And then our diastole is going to look like a longer period of time, but it's just because this is a lot of contraction and action happening in one little section, so it's kind of compressed. So our diastole is going to be our ventricular repolarization, so that's going to be refilling and filling the heart up back with blood so that we can fully take a full circulatory system through the heart. So we're going to start at the bottom. So this red line right here is going to be your ECG reading. And basically in the ECG reading, we take several different steps to have one full contraction of the heart. So in this specific Wiggers diagram, you're going to have 2 contractions of the heart, as you can see, boom, boom, right there. So right here, we're going to have our P wave, and that's where our atrial depolarization is going to start. And then as soon as we hit our systole phase, which is basically our ventricular depolarization phase, during our QRS complex, we're going to see ventricular depolarization. And then as we enter into our T wave and to the point where our T hits back at the bottom of its wave, we're going to enter our diastole period, which is our area of ventricular repolarization. So just to summarize that, we have atrial depolarization, and then through the systole phase, we're going to have some ventricular depolarization happening during a contraction of the heart. And then as we compare this to pressure-wise, this line right here is going to be labeled as ventricular volume, but to be more specific, we can call it our left ventricular diastolic volume. So this is our diastolic end volume, and then right here is our systolic end volume. So the reason that this is going down is because as the heart is contracting, and if we remember our passage of blood through the heart, the left ventricle, is going to take blood, and then it's going to release the blood from the ventricular as soon as the the aortic valve opens, and it's going to pass into the aorta, which takes the blood to the rest of the heart. And that's what happens at the end of a contraction and during the ventricular depolarization and repolarization phases. So the reason that this is going down is because the blood is leaving the left ventricle and then going into the aorta. So this is happening as soon as the aortic valve opens. So if we look at this dotted line up here, this is as soon as the aortic valve is going to open, which is when the blood is released. The pressure is the whole dotted line that goes across right here, this top one right here. So the reason that it is increasing is because as the blood is going through the left ventricle, the blood is passing through the valve, which is causing the pressure in the valve to increase because it's passing from the left ventricle into the aorta. And then we can really see peaks right here that happen during the left ventricular decreasing volume, which basically just means that as this is decreasing, the pressure is increasing. And then when we hit our left ventricular end systolic volume, this is our filling stage, the end of our blood leaving the heart stage. So if we put all of this together, we can basically say that during a full contraction of the heart, the blood is flowing in a circulatory motion, obviously, taking our normal passageway through the heart. And as it's passing through valves and ventricles, the pressure will increase in the valve that it's passing through, and then begin to decrease once it's passing through other parts of the heart, which can make sense because as blood is rushing through the heart, the pressure is going to begin to increase and decrease in a circular motion because blood does flow in a circular motion through the heart.